This is Professor Derf Seitz. This programming tutorial is about recursion. Recursion is a powerful technique that can be used to elegantly solve some rather difficult problems. It's based on a unique usage of method call or function call. We have to understand the call stack. When you call a function, such as this stone down at the bottom here, let's say that's some code, and you call a function from there, you call into the function at the next level, we'll say, and if in there's another call to another function to go to another level, and if this continues, this is what's called the call stack, and eventually at some point one of the functions will return, and it returns back to the caller at the place right where it was called, and this caller can do whatever it needs to do, and finally it will return, and some more code there, and eventually everything returns back. So the call direction is towards what's called the top of the stack up here. The concept of a stack is you put things on top of it and you take things off the top of it as well. So the call order proceeds towards the top, growing taller, and the return order goes back towards the original point of call. Each entry on the stack is a stack frame, and what it contains on the stack is the address of where to return to in the caller, and also the values of all the local variables, including any parameters that were passed in to that function. Because when you return, you have to restore the state of that function, which includes all of its local variable values and parameter values that were passed into it. Now recursion uses the call stack, but the way it does it, instead of just calling other functions, it's self-calls. The function calls itself repeatedly, over and over again. Now if a function called itself with no change to the parameters, we would have an infinite loop. It would just continue this stone down here, let's say this kind of blue one. If it just called itself with no change at all, you would see that blue stone with the same size repeated over and over and over infinitely until you used up all the memory that was allowed for the stack, and you'd get a stack overflow kind of an exception would occur. So that's not how recursion works. That could happen when you're trying to code a recursive program and you don't do it right. What has to happen is each time the function calls itself, it must call itself in a slightly simpler form. So that's why the stones here are shown reducing in size, because the problem is being reduced to a smaller problem. The same problem, but with a smaller scope, so to speak. And at each further call of itself, it reduces it more until finally what happens, you're dealing with a case of the problem that is so easy to solve, it's so obvious to solve, that it's very clear what the answer is for that simple case. Those case or cases where the answer is so obvious are called base cases. You can have one or more base cases. The other calls, the self calls that get simpler and simpler, that's called the general case. And it repeats the general case, calling and calling, until it reaches a very simple base case where it knows what to return, and the base case returns a value. That value is then used in the immediate caller, and then it now has a value to return back to its caller, and the returns propagate or unwind all the way down towards the bottom of the stack, the original call point, finally returning the solution to the problem. Now, recursive solutions, algorithms that use recursion, they can also be coded without recursion. You can code the algorithms using looping, iteration concepts. However, sometimes there are solutions to problems where the recursive solution is much simpler, less code, and it's called an elegant solution. However, there are other times where a recursive solution is not really a whole lot simpler than an iterative solution. And recursion fundamentally is a more complex concept to understand. It's sort of at a higher level of abstraction, the fact of a function calling itself and continuing to do this. So you would only use recursion if you had a clear benefit of an elegant, simple solution. You have to be careful also, because some problems, when you use recursion, the number of calls needed grows at a very rapid order of magnitude, sometimes almost exponentially, and the memory usage is very extreme, and the processor usage as well. So those would be inappropriate situations in which to use recursion. However, it is something, it's a technique used in programming, and programmers and designers need to be aware of it so they can use it when they find a need for it, and also so they can understand other code that was written with recursion.